Welcome back, guys. In this video, let us see what ant colony optimization is all about. Ant colony optimization was one of the first swarm intelligence algorithm to be developed. Ant colony optimization works in the same way as which the ants bring the food source back to their nest, and while bringing so, they tend to find the shortest path between their nest and their food source. So initially, ants try to explore the environment around their nest, and while searching, if they find a food source, they take it back to their nest, and while doing so, they lay something called as pheromones. Pheromones is nothing but a chemical which evaporates over the time. As we saw in the previous slide, whenever an ant finds food, it marks its return journey with pheromones. And while doing so, it lays pheromones, and these pheromones tend to evaporate faster on longer paths. And shorter paths, they serve as a way to food for most other ants. That is, when another ant, which will be randomly exploring the environment, comes in contact with pheromone, it stops randomly searching the environment, and it takes that pheromone trail back to the nest, so that whenever it comes out in the next iteration, it directly goes to the food source and then take the food source and come back to the nest. And while doing so, the second ant also lays the pheromones. So as many ants take this approach, the amount of pheromone laying on the short path becomes large, and gradually the longer ones evaporate, and thus these ants find the shortest route between their nest and their food source. As we saw in the previous slide, the shorter path will be reinforced by further pheromones, and finally the ants arrive at the shortest path. That is, they find an optimized solution from their nest to the food source. Let us see this in action by simulating this scenario. For this, we are using something called as Mason tool, which helps us in simulation of this algorithm. As you can see, uh, we are using initially 1000 ants which try to explore the environment around its nest and then bring back the food. As you can see here, the nest, if you can see clearly, there is a red dot that indicates the nest of these ants, and this red dot indicates the food source. So when I run this simulation, the ants try to explore. As you can see, the ants are trying to explore the environment around its nest, and gradually they are moving towards away from the nest. So as soon as an ant gets near the food source, it starts to lay the pheromone. You can see the pheromone, it will be colored in blue. Yeah, there you go. You can see there are initially two routes found. One route is here, it goes all the way and it comes back like this, and the second route is this route. If you can see, this route is clearly the shortest one, and let's further simulate this process and check out which path will be chosen by the ants. If you can observe this path, the amount of pheromone that is being laid is gradually decreasing, and the amount of pheromone being laid on this part is gradually increasing. And over the course of time, the number of ants taking this path will be reduced, and it comes to nearly zero, and all the other ants that are randomly exploring the environments, they are also becoming less in number. And if we keep this simulation running for quite a bit of time, then all the ants tend to take this path, which is the shortest path between the nest and the food source. In this way, the ant foraging algorithm works. Thank you all for watching, and in the next video I'll explain about how this algorithm is used to solve the traveling salesman problem. Thank you.